Okay, we want to find all the critical numbers, sometimes called critical values, of the following function, and what that means is g prime equals 0, find x. That's all it means. Okay, so first of all, we might hope that we can cancel something, but I don't think we can, so we go ahead and think about this. Could we factor 1? And no, I don't think so. I don't think it's possible. At the very least, we can't factor a y minus 1 out of here, so that's not going to help us. Okay, you could do long division, and then you'd end up with nothing better than what you have. Okay, so we've considered those options. Now we continue, and we're going to go ahead and take the derivative using this nasty thing, the quotient rule. Okay, so bottom times the derivative of the top, and you may say, wait a minute, implicit differentiation, we had to take y prime. Ahaha, but we're just using y as an ordinary variable here, just to mess with your head. Okay, so we don't have to multiply by y prime. Okay, bottom times the derivative of the top, which is just 1, minus top times the derivative of the bottom. Okay, here we go. So now what? The numerator is 0 when g prime is 0. So g prime is equal to 0 if y squared minus y plus 1 minus, okay, we got to expand this thing. What is it? Y times 2y, so we're going to FOIL, and then there's a minus outside. So you get 2y squared, and the O term is minus y, it becomes a plus y. And the inner is minus 2y, so we get a plus 2y. And the last is plus 1, so we get a minus 1. Okay, let's put this here. Let's see, we get minus 2y squared plus y plus 2y minus 1 equals 0. Let's combine these. Y squared minus 2y, so we get minus y squared for these pieces we used. Now let's collect up all the y's. These guys cancel, and then you just have 2y. And then we just get minus 1 and plus 1, so that disappears. Aha! That makes it easy. This is a g, not a y. Okay, so this, the y factors out, and you get minus y plus 2. There we go. So y equals 0 and y equals 2 are roots. And again, I'm sorry. Does it bother you that it's a y instead of an x? Because I even said find x. I meant find the independent variable, and in this case it's y. Sorry. Okay, this rational function, we are lucky, actually has no division by 0. But that's a surprise. Okay, might have asymptotes. And remember that we had a list of instructions on how to plot rational functions. Might have asymptotes if y squared minus y plus 1 can be 0. Let's see if it can, okay? If y equals, remember this is the quadratic formula, so it's normally put x equals negative b plus or minus square root b squared, take away 4a c all over 2a. Doesn't matter. Negative discriminant, no real roots. Now that could mean that there's no zeros, but it doesn't tell us whether this whole denominator is strictly positive or strictly negative. But we know that it's strictly positive because of that squared value up here. We know that, for example, you chuck in y equals 10, you know the denominator is positive. Okay, so that's interesting. So now what do we know? We're going to start poking at this. Since, if you wanted to, you could have just changed y to x at the very beginning of this problem and left it that way, and I kind of wish I did because it's getting annoying. Okay, g of 0 equals minus 1, right? Because you put in 0, 0, 0, and you got minus 1 over 1. That's easy. And now we've got to find the other critical point, g of 2. So you chuck 2 in here, and you're just going to have to trust me on this. That turns out to be 1/3. And it seems obvious that you just want to pick g of 1 because it's easy to calculate. Alright, just for fun. Alright, so we have a point here. We have a point here that has a horizontal tangent line at 2. I'm sorry, at 1 it's 0. Put that in the wrong place. Sheesh. And then this guy at 0 it's negative 1. It's down lower. You know the long-term behavior of this guy, because the denominator has a power that's higher than the numerator, right? So we have long-term, I'm sorry it's going to be messy on the page, I don't have much space. Long-term we have y equals 0, except it's not y, I'm sorry, it's g equals 0, because we have this crazy variables going on. G equals 0 asymptote. Okay, so we have to start looking at the derivative more carefully here. Right, so we have, this is our, we want to see what's going on with the numerator. Since the denominator is strictly positive, the sign of the derivative, sign of the derivative, is important to us. So let's just think about plotting minus y squared plus 2y. Just for a second, let's just figure out what's going on. So we said there's a 0 at 0, and there's a 0 at 2, and it's a minus y squared, so the thing is facing like that, right? So if this is g prime shares sign with this guy, it's not equal to that guy, it's not even proportional to that guy, it just shares the same sign. So between 0 and 2, g is increasing, otherwise g is decreasing. How's that? G is decreasing just about everywhere except from y, which we're used to thinking x, but over this interval g can increase, otherwise it's decreasing. So what we're saying is between here and here it's increasing, and otherwise it's decreasing. But we know it has an asymptote, so it must go like that. Has an asymptote, so it must go like that. So that's all it can do. It's kind of a boring function actually when you think about it. It's like sort of a twisted bell curve of some sort. But, you know, sorry, that's all I can tell you because that's all it's doing. Again, if it's not an exam, you can check with Wolfram Alpha, but it's an exam, so you just got to go with your gut.